Hey everyone, hope you're all doing well. In today's video, we are going to be talking about how to factor a quadratic. And you might be thinking, um, why do we factor a quadratic? And we learned factoring with different equations in the last video, so now we're going to be specifically talking about why we factor quadratics. And the reason we factor quadratics is because it gives us the x-intercepts of the equation, and the x-intercepts are also known as zeros, which is a very important term you should know. And the x-intercepts give us solution for the quadratic when the quadratic is equal to 0, right? Because if we have the basic quadratic of y equals ax squared plus bx plus c, right? If in any equation given, for example, if we wanted to solve for um, this x value right here, right? We would have to set y equal to 0, right? Because y, if we look at a graph, for example, y is this axis right here. And the x-intercepts, y value is always going to be 0 because it's always going to be going through the x-axis, and that's just where y is equal to 0. So that's why we set the whole equation equal to 0. And then we can just repeat this again, ax squared plus bx plus c, and we can factor this to get our zeros or solutions for the quadratic equation. There's other methods you can do also. Instead of factoring is just the easier way of getting the x-intercepts. Sometimes factoring does not always work, so we would have to use the quadratic formula. And the quadratic formula is fairly simple to use. I'll write it down. In this video, we're not going to go too much over it because it's just substituting in values and getting an output. But the quadratic formula is just x equals negative b plus or minus the square root of b squared minus 4ac over 2a. You will most likely need to memorize this formula, but it's not that hard to remember. I remember it after maybe a year now, right? It's not that hard. And yeah, that's just the quadratic formula. You sub in your, give me a second, let me change the color, your a, b, and c values into these values in the quadratic formula. It's not that hard, fairly simple. But in today's video, for today's video's purpose, we are going to look at how to factor quadratics. And starting off with the first example, you might be thinking, how do we factor this? Because all the techniques, right, that you've probably learned or you looked at in my other video, these don't look like they can use those techniques. So you might be thinking, how do you actually factor a quadratic? It's not that hard. All you have to do is look at the last term and then look at the middle term, right? For this question, it can get more complex if there is an a value, right? Because remember, this still is in the format of, give me a sec. This is still in the format of ax squared plus bx plus c, where in this case, your b value will equal -2, right, as we can see here, and your c value will equal -15, right? And your a value will equal 1 because there is an a here, but it's just 1, right? Because you're only left with x squared. So then that's basically it. You're given the b and c values, and that's what you have gotten to so far. Now, how do we factor? So we look at the last term and the middle term. We find two numbers that, I should probably write it down. So what that basically means is two numbers that multiply to the last term, and the last term is your c value, which is -15, but also add to your b value or your middle term, which is -2. So let me quickly label this. So this is going to be your middle term, and this is going to be your last term. So now, this takes a little bit of process of elimination. What are two numbers that multiply to the last term but still add to the middle term? And you take however much is time. It's once you get the hang of factoring quadratics, it's very simple. So in this case, two numbers that multiply to the last term but add to the middle term would be 5 and -3. And I'll show you why 5 and -3. Because look, negative 5, -50, -5 times -3 equals -15. I mean, -5 times 3 gives you -15, which is your last value, so that works. And then -5 plus 3 will give you -2, which is your middle term. So therefore, this will still work. This will work. So there are many ways on how you can start the process of factoring. One of the ways that I personally do it is by a method called decomposition. And sometimes decomposition can get long. I personally do it because I can do it pretty fast. There are shorter methods that your teachers may show you, but for the purpose of this video, I'll just show you decomposition because you'll always get the right answer by using it. So what you're going to want to do is now write down the equals, and you're gonna repeat it. X squared. You're gonna repeat that term, but now you know the two numbers that are gonna add to the middle term are -5 and 3, which will also multiply to the last term. So all you're going to do is you're going to do -5x plus 3x. And you might be wondering, why are you adding the x? The reason you need to add the x is because your middle term is -2x, right? So you just by default have to add the x, right? And you will still get the exact same answer. And then just repeat it again, -15, right? And we've got to this point. Now what you're going to want to do is group the first two terms and the last two terms. The last two terms. Once you group the first two terms and the last two terms, you are going to factor out anything common between both of the brackets, right? So if we factor something common between both of the brackets, in this bracket, we have what's common is x, so then we're going to be left with x minus 5. And what is common in this bracket is 3, because 3 can go into -15, and there's no x value with -15, so we can't factor out x. So we're going to be left with plus 3 x minus 5. And then after that, using common binomial factoring, right, we can just simply factor out x minus 5, because that's the common binomial. So then we're going to be left with x plus 3 x minus 5. And if you still don't see how I got x plus 3 and x minus 5, you can always do that let statement that I said in my first video. Let y equal x minus 5. So then it's going to be xy plus 3y. Now, if we factor out y, we're left with x plus 3. And what does y represent? X minus 5. And then we just repeat x plus 3. And it's the exact same answer as this. It's switched around, but multiplication will give you the exact same answer, right? And that's basically for factoring for this type of quadratic, right? The next one is basically the same process. Okay, so now you're going to take this information that I showed you here, finding, it's called also the sum and product rule. You could also think, it's called the sum and product rule, right? Finding the sum of the middle term, which is your b value, and the product of the last term, which is your c value, right? And we'll do this question right now. Now, we find two numbers that when multiplied give us negative 28, but when added give us positive 3. So, let's think. Negative 28 and positive 3. We could do, let me think, 7, 14. We can do 7 and 4, for example. And you could do 2 and you can use multiple. There are many numbers you can choose from. That's why it's a process of elimination. It's a guess and check, right? And I'll show you right now. If I used, for example, 2 and 14, 2 times 14, right, equals 28, right? Or in fact, we could even do 2 minus negative 14, which gives us negative 28. So that gives us our, that automatically gives us our C value. But if we do 2 plus negative 14, no, did I say 48 before? Sorry, my bad. Negative 14. 2 plus negative 14, that will give us, well, I can't do math. That will give us negative 12, right? And that's clearly not our B value, right? So we cannot use 2 and negative 14. So another value that would actually work is positive 7 and negative 4. So let's check that. 7 times negative 4 equals negative 28. Yeah, that gives us our C value. 7 plus negative 4, that gives us our 3. So therefore, those two values work because it gives us our middle term and our last term. So if we use decomposition, y equals x squared, and then we take these values and we just write them out again in that like B type of section, right? Like by default, you have to add x to them. So you're going to be left with plus 7x minus 4x. And again, it does not matter if you put, for example, minus 4x here and plus 7x here, right? You'll still get the same answer. So plus 7x minus 4x minus 28, we follow through with the equation, right? So yeah, we put those two values right there in the middle of the equation. And then using decomposition, again, we group. You don't have to do these steps. These are just extra steps to show you guys. But it's just good practice for you. And yeah, so what you're going to want to do also here is, since there's a negative sign right there, right? Since there's a negative sign right there, what's also helpful with decomposition, if you just add plus and then bracket negative 4x. And the reason plus is because in most cases, you can actually factor out the negative, right? So it'll make your life easier. Because if you had the negative, let's first say outside, right? I don't think it would change your answer necessarily, but it will just be written like completely different. Like, look, see, you're going to have minus outside and then 4x minus 28. You can't forget that minus is outside, right? Because that minus is technically still with the 4. It's actually still technically with the 4. So it's much better if you just do plus, minus 4x minus 28, just like that. And then, again, you look at what's common between the brackets. X is common, so you're going to be left with x plus 7. What's common between this bracket? Negative 4. So then you're going to be left with x plus 7. So then, just by looking at common binomial factoring, you're going to be left with x minus 4, x plus 7. And then that would be your factored quadratic. And then later on, when we're doing graphing, I'll tell you what these values give you. And that's basically it. Oh, I just realized the most important thing I forgot to be telling you guys is in the beginning, always set y equal to 0. And the reason 0 is because, remember, the only way we can factor is if we set the equation equal to 0. If we set y equal to 0, that will let us isolate for x. It's more of a communication thing. Obviously, like, it doesn't mean that much. Setting it equal to 0 just shows that, okay, we're isolating for x. If you just leave it as y, it's not technically right communication. So yeah, you just have to set it equal as 0, as I explained before in the beginning. And now you're going to get another one like this that I'll go over. If you can't see already, this is one of the factoring techniques that we actually covered and is a quadratic because it's raised to the power of 2. It does not have that bx term, but it's still a quadratic since it's raised to the power of 2. If we were to factor this, I'll give you a second because it's one of them, and like one of the most common methods of factoring that you will see. And in this case, it is difference of squares. So the difference of squares type of skeleton equation calls for a minus b, a plus b, right? So if we set it equal to 0, because we're isolating for x squared minus 49, and if we use the a minus b, a plus b formula, we'll just be left with 0 equals x minus 7, x plus 7. And again, it can also be x plus 7, x minus 7. It does not matter because multiplication, again, when you FOIL it out, will give you the exact same answer. And that's basically it for that question, right? And yeah. Now this question is a little harder. You will need to, there's an extra step in this question. And that extra step that you have to do is you have to take your a value and multiply it by the last value. You might be asking, why should we do this, right? That's just kind of the rule. If you like, it's, you could use like the quadratic formula to solve this, but it's always easier to see if you can factor it. And if you have an a value, it gets a little bit more complicated since you have to use this rule of multiplying the a value by the c value. So if we do multiply the a value by the c value, and we also take that negative into consideration, you're going to be left with negative 120, right? So what do we do with negative 120? So before, we had to figure out two numbers that multiply to the last term but add to the middle term. Instead, we are going to find two numbers that still multiply, that still add to the middle term, but now multiply to this term right here, right? So if we do figure out two numbers that multiply to that but still add to positive 2, so now it's two numbers that multiply to negative 120, but two numbers which added give you positive 2. Now let me take out my calculator and see. You're allowed to use a calculator for these questions, because there can be much bigger numbers, right? Let's try 10, for example. Negative 120 divided by 10. Oh, my bad. Negative 120 divided by 10. That gives us 12. Okay. And just a lucky guess, I picked 10. You could pick 5. But again, it has to fit the rules or criteria in this case, which again add to 2, but the two numbers add to 2 but multiply to negative 120. So if I pick 10 and 12, right? I know one of them has to be negative because I'm going to get a negative value, because when I multiply them, I'm going to get negative 120. So let's say I choose, oh, my bad. Let's say I choose negative 10, right? Then I'll be left with 12 times negative 10 gives me 120. Okay, negative 120, which is correct. And then if I do 12 plus negative 10, what does that give us? 2, right? So that will work. That will work, right? I mean, if we switch the operations around, if I had negative 12, I would be left with negative 2, which is not correct. We want positive 2. Okay, so now we found our values. So we can use decomposition like before. Y equals, we're going to copy that 8x, right? Just like before where we were copying x squared. 8x squared, copy the middle terms. Again, it doesn't matter what order. minus 10x plus 12x minus 15. So now, again, with decomposition, we group the first two terms, and you don't have to show this step again. As I said before, oh, my bad, 12x minus 15. So now we look at, oh, again, bad habit, I forgot to equal it to 0. Once you write it equal it to 0, you don't have to do it like 0 again, right? Because then you just know. Now, what's factorable between in this bracket? 2x, because 8 is divisible by 2, and 10 is divisible by 2, and they both have x. I'm going to be left with 4x minus 5, and for this bracket, 12x minus 15, what is factorable is 3. Not x, because they both don't have x, so just 3 itself. 4 divided by 3 is 4x, 15 divided by 3 is 5. And again, you get two common binomials, so you just factor out the binomials. So then you're going to be left with 2x plus 3, 4x minus 5. And that will be your fully factored form. If you FOIL this out, again, like I said in factoring, if you FOIL this whole thing out, you will be left with your original equation. And that's basically it. That's how you factor that. This one now. This one looks complicated because you would think it's a difference of squares, but again, 3 is not a perfect square and 75 is definitely not a perfect square. So, in all questions, what you try to also do in factoring is you look first if the whole thing has a greatest common factor, right? Can you take anything out? That's usually what you do first. These ones, they did not have a greatest common factor, so we couldn't factor anything out. And so for this one, we can factor something out. Usually we factor, in most cases, what is common, obviously what is common between all terms. In this case, the a value is common, because if we do factor out 3, we are left with 3x squared minus 25. Negative 75 divided by 3 is negative 25. So now we can see what we can do further. This right here is a difference of squares. Let me write it. Sorry, difference of squares. So again, if we use the difference of squares formula, we are just left with y equals 3 x minus 5 x plus 5, and that's our fully factored form, and that's it. Now moving on to this one, we look at, can anything be a greatest common, is anything a greatest common factor that we can factor out? So we look, looks like there is none. And in this scenario, you wouldn't actually need to find a greatest common factor, because look, this is 9 is a perfect square because the root of 9 equals 3, and 64 is a perfect square because the root of 64, wow, that's a bad 64, give me a second. The root of 64 equals 8. So now it's a difference of squares, right? So we can just use the difference of squares formula. We can do 0 equals 3x minus 8, 3x plus 8. And that will be our final form. And I have these two at the bottom for you guys. You guys can try them out. I'll do full solutions right now, and then I'll not repost, but they'll be later on in the video, probably like 30 seconds after this, not even. And yeah, I have finished the solutions for these, so I hope you tried them. They were interesting answers, right? Because some examples I didn't go fully over. If you look online, there are other questions, which the more practice you have, the more you will understand, the more you will get it. That's the only way I learned. And yeah, that's basically how you factor quadratics and all the techniques there is to factor quadratics. And that's basically it, everyone. I hope you enjoyed this video and learned how to factor quadratics. Please subscribe and like please subscribe to my channel and like the video if you enjoyed it, and give any feedback if if you think I need any. And that's basically all. Take care, everyone. Have a great day, evening, night, or whatever time it is for you. Bye.